Say regarding collision of subatomic particles, two dimension, only the practical background, practically what happens, that has to be accepted. Because some of the some of the questions are there, even I feel very strange when I look at that one, because the reason is practically it occurred to have that practical to explain that thing which is practically no, they assumed a theory. So some of the collision of subatomic particles. So I think definitely the professor who is trying to ask questions, he will keep these parameters in mind. He will not bring some unknown thing where student they don't know first time. Not possible. Nobody can make a guess. No, you can't make a guess in two-dimensional collision. So definitely the question that will be asked will be within the limits where a student can imagine. Okay, this is they are dropped from a height. After dropping, just they are about to strike the ground. Okay, there's a ball. There's a big ball, heavy steel ball, and there's a small ball. Extremely light steel ball. Heavy steel ball held in contact with extremely light steel ball at height h. Okay, they'll come and collide as this is a heavy steel ball. Okay, no. Okay, this will collide. It will rebound. So mass of this be m2. Let this be m1. So this will, after collision, like this will assume something. So now you can ask it like, so what actually you're doing? Both are released, they're in contact. First, this will collide. And as the elastic collision, it will rebound with the same speed. Now there'll be a collision between these two. So what is this diagram? Collision. Big ball with ground. Next, what is this? Collision of small ball with big ball. So now we'll define the common tangent and common normal. Already did that. So here also common tangent and common normal you begin. So let this be the T cap. And let this be the N cap. Horizontal range of the lighter ball is asking horizontal range. I think horizontal range you can find out if you know V1y and V1x. Let the mass of this be M1. If all the collisions are elastic and sizes of the balls are negligible as compared to height h. So what is U? U, we know it very well. I think you should always think to minimize mathematics. So why only, sir, you are doing like this here? Because I can do this in along X, along Y, but it's advisable to discuss this entire whole problem along T cap, along N cap for the lighter but small ball and along line of impact. That'll be a better idea. Can we conserve momentum along x-axis? Yes, you can write it. Along momentum, along x-axis, you can conserve. Along y-axis? No, there'll be some impulse now. No, there'll be some impulse here by the ground.
After collision, we can conserve now, sir.
Okay, after collision, you can write it for this one. Okay, there's overall first collision. First, the big ball will collide. Then the small ball will collide with the big ball. And with respect to the, like this big ball will wave like a wall with respect to small ball. This will treat, this is like a wall. The ball will now collide. So this big ball weapon will become like a wall for the small ball. Treat it as a wall for small ball impact. For small ball. Okay, now let me apply conservation of momentum along line of impact, along T cap.
Momentum we cannot conserve, no, sir.
For small ball along T cap. Net impulse will be zero, no? Because what all the impulse will act along line of impact, it will act. The impulse will be acting in direction. So for small ball, what will happen? I can write along T cap. Along T cap initial momentum m1 u sine theta. Okay, this is I define that as theta. This will be theta, no? So m1 u sine theta should be equal to m1 v1x cos theta minus m1 v1y sine theta. Theta is available for us, so I get one equation now. U by 2 equal to v1x root 3 by 2 minus v1 by 2. Keep it equation 1. What is another equation? We can write it. Quotient of each equation. Shall we write it? E equal to 1 E as given. So collision of the, this will be theta. So that of the ball, heavier ball, u cos theta. Let me take this direction as positive. U cos theta minus v1y cos theta v1x sine theta. What is the other equation? Minus u cos theta, that of the small ball. This is, this will be for small ball. Okay, for, I'll give blue color. Such questions I think can be asked in exam because there won't be any. All these are related to small ball. You see the terms. Okay, no problem. This is so substituting the value of theta and as e equal to 1, we'll get one. How many unknowns are there? v1x and v1y. If we can get that, I think problem solved. This will be 1 u by root 3 by 2 v1y root 3 by 2 plus v1x by 2 is equal to minus u by root 3 by 2. I think 2 equations to unknown. Solving this will get the required answer. Okay, we'll write it. One more step, I'll write it. This will be minus u root 3 by 2 v1y root 3 by 2 minus v1x by 2. Solving the equation 1 and 2, we'll get v1x and v1y. After getting v1x, I can get the time period. What is the time period? 2 v1y by g. What is the range? Range will be v1x into t. I'll show the complete problem. Very comfortably. Within 4 minutes, I think we can solve this, nothing big. Okay, this idea is very important. I think you can really minimize so many calculations. See, you can do this problem by applying conservation of momentum along x-axis. Will be very lengthy. Again, you have to write this component of this. This will be better approach, no?